Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. We will continue our lecture Async Chapter 2 Analog Modulation, uh, Part 3. Okay, today we will discuss about AM envelope, Amplitude Modulated Signal envelope. So we have discussed about the envelope in previous part. So given a signal representation as follow: carrier signal VC sine omega t or 2 pi fc t, modulating signal Vm sine 2 pi fm t or omega m t, and the modulated wave, the AM modulated wave is VAM, amplitude modulated signal. T is time. When a modulating signal or information signal, this modulating signal Vm sine 2 pi fm t is applied to the carrier signal is Vc sine 2 pi fc t, the amplitude of the output wave varies. The amplitude of the output wave is modulated wave or envelope, the envelope, AM envelope. This is the output. The amplitude of the envelope varies in accordance to the modulating signal, this modulating signal. So the amplitude of this modulated wave varies according to changes of modulating signal. Modulation index and percent modulation. The ratio of maximum amplitude of modulating signal to maximum amplitude of carrier signal is called modulation index. So modulation index is the ratio. Modulation index is the ratio M of the ratio between amplitude of modulating signal to the amplitude of carrier signal. The maximum value, the maximum amplitude of both modulating signal and carrier signal. The value of EM must be less than the value of EC to avoid any distortion in the modulated signal. Therefore, maximum value of modulation index will be 1 when EM equal to EC. Minimum value will be 0 if the modulation index is higher than 1. Then it's called overmodulation. So overmodulation is not good. It can be loss of data. The data can be lost in the case of overmodulation. So the maximum is 1. The best or good is 1 as long as EM is less than EC. So we will have modulation index less than 1. If EM is more than EC or higher than EC, we will have modulation index more than 1 or higher than 1. Then it will become overmodulation, and it is not good for data transmission because the data can be lost. When modulation index is expressed in percentage, it is called percentage modulation. So 1 is equal to 100%. So anything less than 1 could be less than 100%. Okay, so if we present the modulation index in terms of percentage, we call it percentage modulation. So calculation of modulation index from amplitude modulated envelope waveform. So this is the envelope. Okay, so from this envelope we can calculate the modulation index. We can derive the modulation index. So these are the value of each of the parameter in the equation question of modulating signal, carrier signal, and amplitude modulated waveform. So let's say from here, so we have this from 0 to max of carrier, we have EC. What is EC? EC is maximum amplitude of the carrier signal, EC. So here we have EM. EM is the, so we can see from here, okay, here is the amplitude of EM. EM is the maximum amplitude for modulating signal. Modulating signal, we take this line as the signal. This is the imaginary, yeah, because amplitude, the envelope. Okay, so EM is here. So we have Emax. Emax is the maximum amplitude of the envelope. Emax. Emax is from 0 to the maximum amplitude of this envelope. And we have E-min here. E-min. E-min is the difference between EC, this one, and EM. Okay, EM. So this is EC. This is EC from 0 to here, and we have EM from here to here. So the difference is E-min. Okay, so you can study this later. Okay, AM frequency spectrum and bandwidth. So when we have the envelope of amplitude modulated signal, so we can discuss that signal in terms of a frequency spectrum, meaning that this is the frequency domain and bandwidth. So in terms of frequency domain, we have the amplitude and the frequency. Output envelope is a complex wave. Output envelope, output AM amplitude modulated signal envelope is a complex wave made up of DC voltage, carrier frequency, some frequencies. Carrier frequency is FC. Some frequencies is FC plus FM. Different frequencies is FC minus FM. AM spectrum range from FC minus FM max to FC plus FM max. So wherever we have a frequency range, there is represent the bandwidth. So let's see this figure. So we have this frequency spectrum, amplitude versus frequency. So this is the envelope. Okay, so let's see we have three frequency here. We have FC, the carrier frequency, and here we call it F minima, F min, which is FC minus FM. FC minus FM. So here we call it the upper frequency. This is the lower frequency. This is the upper frequency. Upper frequency is FC plus FM. So this part is called lower side frequencies or lower sideband, and this part is called upper side frequencies or upper sideband. Upper sideband and lower sideband. So AM frequency spectrum is drawn in this figure, and we have lower frequency and upper frequency, lower sideband, upper sideband. So okay, frequency spectrum and bandwidth. The modulated carrier has new signal at different frequency called side frequency and sidebands. They occur above and below the carrier frequency FC. So FUSB upper sideband is FC plus FM. FLSB lower sideband equal to FC minus FM. Here FC is carrier frequency, FM is modulating signal frequency, LSB is lower sideband frequency, USB is upper sideband frequency. So consider the expression of AM wave given by equation previous has been discussed previously. So EC plus EM, this is the envelope equation. We know that M equal to EM over EC. We have discussed this. Hence, we have EM equal to MEC. So solving this equation for EM, so we have EM equal to MEC. Putting this value of EM to the above equation, so we expand this equation. EC MEC sine omega MT sine omega CT blah 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 blah. Okay, so we have this sine of cosine. So as we know, this is the trigonometry. Sine A sine B equal to half cos A minus cos B minus blah blah. Applying this result to last term is in above equation, we get this equation. Solving this, we get this equation. In the above equation, the first term represent unmodulated carrier, the second term represent lower sideband, the last term represent upper sideband. Note that the omega C equal to 2 pi FC and omega M is 2 pi FM. Hence, above equation can also be written as. So this is the equation for envelope. So we have three parts of the signal. First is unmodulated carrier. So this is the carrier signal unmodulated. Second part is lower sideband. So we have this lower sideband. How we know that this is lower sideband? Because the frequency is minus. FC minus FM is the lower sideband, and the last term represent the upper sideband. Last term is this one. So we have this amplitude and frequency here. So frequency is FC plus FM, which is upper sideband. So we can see that this the amplitude is similar, MEC over 2, and this is the frequency is, this one is, the lower is FC minus FM, the upper is FC plus FM. So this is the equation for envelope, AM envelope signal. So from that equation, we can analyze the equation in terms of a frequency domain, where we have the amplitude and the frequency spectrum. Frequency domain, representation of AM wave. So we have the amplitude and frequency. Okay, so what is that? We have the amplitude of MEC over 2 at the frequency FC minus FM, which is lower sideband. We have the amplitude EC at the FC, the carrier frequency, and we have the amplitude of MEC over 2 at the upper side frequency, FC plus FM. This is the frequency domain representation of AM wave. This contains full carrier and both the sideband. So this envelope contains carrier and sideband, lower sideband and upper sideband. This contains full carrier and both sideband. Hence, it is called double sideband full carrier, DSBFC. So previously we have seen DSBFC. So this is the frequency domain, frequency spectrum of double sideband full carrier. We will be discussing this system, its modulation circuit and transmitter next in this section. As we know, the bandwidth of the signal can be obtained by taking the difference between highest and lowest frequency. From the above figure, we can obtain the bandwidth as BW. The bandwidth is upper frequency minus lower frequency. So upper is FC plus FM, minus FC minus FM. So bandwidth is equal to 2 FM. 2 FM is, so this is the range is FM, and this is the range FM. So the bandwidth of the signal is 2 FM from here lower to upper. AM frequency spectrum and bandwidth parameter. So this is the frequency spectrum. Lower sideband here, lower side frequency, okay, any frequency between this range. Upper sideband, band of frequency between FC, any frequency here. Upper side frequency, any frequency in upper sideband. So bandwidth is twice the highest modulating signal frequency. So bandwidth is twice or double the FM. So this is the example. Calculate the modulation index and percentage modulation if given voltage of the signal is 40 and 50. Given this, so how to calculate the modulation index? Modulation index is EM over EC. So just insert the value. Percent modulation, this one multiplied by 100, so 80%. Another example, the tune circuit oscillator is AM transmitter, 40 microhenry coil and 12 nanofarad capacitor. If the oscillator output is modulated by audio frequency 5 kHz, what is the lower and upper sideband? So the frequency is given as 1 over 2 pi cert LC. So putting the value, we get the frequency at 230 kHz. So the modulating frequency is FM. So this is FC. Modulating frequency is FM 5 kHz. So USB is upper sideband FC plus FM 235. LSB lower sideband FC minus, so 230 minus 5, 225. So the bandwidth is double of this modulating signal, which is 10 kHz. So that's all. Hope you can understand. Thank you very much. Assalamualaikum.